Dear students, myself Dr. Mallikarjun S. Biradar, Assistant Professor in Mathematics, Government First Grade College, Basavakallam. In the 37th session of Graph Theory 2, we are considering a theorem on chromatic number of a tree. So, if you consider a tree, what is its chromatic number? It is a special case. Okay. So, let us consider the tree. So before that, we recall what we have discussed in the previous sessions. So we need what is n-chromatic graph and bichromatic graph. Okay. Already we know what is chromatic number of a graph. The chromatic number of a graph is the minimum number of colors required to color a graph. Okay. Then if you are using n minimum number of colors to color that graph, so therefore, n will be the chromatic number of a graph. So what do you mean by n-chromatic graph? A graph G is called n-chromatic if the chromatic number of that graph is n. Okay, if the chromatic number of a graph is n, then it is called n-chromatic graph. For example, in the previous class, we have considered a cycle with three vertices, so C3. So C3, it was three chromatic. C4, when we have considered C4, it was 2 chromatic. Okay, so like that we have considered some examples in the previous sessions also. So let us recall once again what is n-chromatic graph. A graph G is called n-chromatic if the chromatic number of that graph is n. So what is bichromatic graph? Bi. So if it is a 2 chromatic, then it is called 2 chromatic graph, or you can say bichromatic graph. So a graph G is called bichromatic or 2 chromatic if the chromatic number of that graph is 2. So okay, so this is about the n-chromatic graph and bichromatic graph. Okay, so with these recapitulations, let us consider one example. Write the chromatic number of a graph T. So what is T here? Where T is a non-trivial tree. So you know already the definition of a tree. If I ask you to define a tree is a connected acyclic graph. Trivial tree means only one vertex. Non-trivial means more than one vertex. Okay, so it is a non-trivial tree. So what do you mean by non-trivial tree? A graph which is connected and acyclic, then that graph is called a tree. Okay, so we know the concept of a tree, but our aim is to find what is the chromatic number of a tree. So here we have considered one example. So write the chromatic number of a graph T, where T is a non-trivial tree. So let T be a non-trivial tree as shown in figure 1. Let us consider. I have considered one tree here. So this is the tree which is a connected graph and it is acyclic. There is no cycle at all. Okay. So such a graph is called a tree. So now what you have to do, again say in the same fashion how we have colored in the previous graphs. You start with any vertex and start assigning the colors to the vertices. Say for example, we have assigned this vertex by the color 1. And these two are adjacent vertices, so you have to assign the color 2 because you cannot assign 1. When it is assigned 2, the vertices which are adjacent with this vertex are not assigned the color 2, so you have to use another color. So for that reason, these two vertices are colored with 1. So like that, if you consider again this vertex, okay, you cannot assign 2 but you can assign 1. So when you assign a color 1 to this vertex, the vertices which are adjacent to this vertex, you cannot assign the color 1. So what you have to do? The adjacent vertices are colored with 2. Here also 2, here also 2, here also 2. So like that, if you assign the colors in such a way that the adjacent vertices are having different colors. So keeping that idea in your mind, if you color a tree, this is a tree. So what is your observation? What is your observation? So first we have started at one vertex. Okay, let me consider in a different way. If you consider a vertex and the vertices at odd distance and even distance. So this is a vertex at odd distance. So what do you mean by distance? The number of occurrences of edges. Here only one edge is there between these two vertices. So one edge means it is odd. Okay, so number of edges are only 1. So therefore what you can say, this vertex is colored with 2. So at odd distance, so this vertex is at an odd distance, so it is colored with 2. You can see this is a vertex. What is the distance between this vertex and this vertex? They are at odd distance, 1 edge, 2 edges and 3 edges. Okay, even if you consider this vertex, so the distance between this vertex and this vertex, the number of occurrences of edges are 1, 2 and 3. So therefore I am saying about the edges, 3 edges, that is odd length. Okay, if you start with any arbitrary vertex, the vertices at odd distance are colored with different color other than the color which are used for the starting vertex. Okay, so similarly, if you think of the vertices at even distance, for example, you have started with this vertex as a color 1. If you consider the vertices at even distance, so this is at even distance. So between these two vertices, how many occurrences of edges are there? 1, 2. So they are at even length. So whenever the vertices are at even length, they have assigned the same color as 1, 1 only. Even if you consider this vertex, so they are at even length. Again the length is 1, 2. Okay, so the color is same, 1 only. Even if you consider this vertex, so between this vertex and this vertex, what is the length? Number of occurrence of edges? 1, 2, 3, 4. It implies these two vertices, this vertex and this vertex, they are at even length. So whenever the length is even, same color we have used. So this is very important observation. So in a tree, if you start assigning the color at any arbitrary vertex, you have to observe the vertex at odd distance are colored with the different color of other than the color which I used, but the vertices at the even distance are used the same color which you have assigned for the beginning or the initial vertex. So this observation helps you to prove one of the important result. So overall conclusion in this example is that this is a tree and we have used only 2 colors. Okay, so therefore these are the minimum number of colors. So that's why the chromatic number of a non-trivial tree is 2. So this is the conclusion. Okay, so we took one example. Let us consider a theorem. So suppose a tree with at least 2 vertices. Suppose if you consider a tree with at least 2 vertices, then that tree is definitely bichromatic. Consider a tree with at least 2 vertices. It implies you are considering a non-trivial tree as that of the previous example. Okay. If you consider a non-trivial tree, then that tree is definitely bichromatic. What do you mean by bichromatic? The chromatic number of that tree is 2. So already we come to know from the previous example. Okay. But we need to prove this result. So okay, for that reason what you have to do in the proof, let T be a tree with at least 2 vertices. It implies it is a non-trivial tree. Thus, it is connected. As I said, a tree is a connected acyclic graph. So definitely that graph is connected with at least one edge, because when it is with at least 2 vertices, when it is connected, obviously there exists at least one edge. So thus it is connected with at least one edge. Okay. Hence T is not one coloring. Whenever there is an edge, one edge is nothing but it is adjacent with exactly 2 vertices. It implies if you assign one color at the one end, you have to assign the another color at the another end. It implies if E equal to UV is an edge, if you assign the color 1 to vertex U, you cannot assign the color 1 to vertex V. You have to assign the color 2 other than 1. It implies if there is an edge, definitely it is not one chromatic, because we need at least 2 colors. So for that reason, what we are going to say, hence T is not one coloring. So therefore it may be more than 1, maybe 2 or maybe 3. Let us see what happens. Let V be any vertex of a tree. as we have discussed in the example, you start with any vertex. Say, let V be any vertex, any arbitrary vertex of the tree. Okay, for this vertex, we assign color red. In the example, we have used the color 1, 2, 3. But here specifically I am saying you have to assign the vertex V and by the color red. Okay, so V is assigned with the color red. And what you have to do, assign color blue to all adjacent vertices of V. Okay, when V is assigned by red color, the vertices which are adjacent to V must be assigned by another color. So what would be that color? That color would be the blue color. So assign blue color to all vertices which are adjacent to V. Next, assign the vertices adjacent to these. Adjacent to these means which are assigned by the blue color using color red. You can use the previous color, red color. Okay. So repeat this process till every vertex in a T has been colored. So therefore, if I recall once again the previous graph, or you can say the tree. Okay, suppose this is the color 1. Instead of 1, you can say red color. So when it is colored with red color, the vertices which are adjacent with red color, you cannot assign red. You have to assign another color, say the color 2. Instead of color 2, you can say blue color. Okay, so when this color is this vertex is assigned with blue color, the vertices which are adjacent to this vertex should not be colored with blue, but you can use the red color. So like that, 1 1 1 1. So 1 is nothing but red color, 2 is nothing but blue color. So here if you observe what happens here, the vertices colored with 1 and the vertices colored with 2, like that the adjacent vertices are with different colors, but the vertices at even length and odd length, what I said. Okay, or you can say you can continue this process. So that is also another way you can say. Okay, so in that way, if you color all the vertices, or you can repeat this process till every vertex in T has been colored. So now after coloring, you just observe. Hence all vertices at odd vertices. Hence all vertices at odd distances, not odd vertices, odd distances from the vertex V have colored blue. As we have observed in the previous graph, we have started with the vertex and assigned the color 1. So where we have assigned the color 1, the vertices which are at even distance, odd distance, so that observation we had. Okay, so the vertices at odd distance are colored with 2. The vertices at the even distance are colored with 1. Okay, so that is very interesting observation. So therefore, hence all vertices at odd distances from V have color blue, while V and vertices at even distance from V have color red. It implies what you can say, overall the tree is colored with only 2 colors. So therefore, T is a 2 coloring graph. Hence, it is bichromatic because only 2 colors were used. Those are the minimum number of colors. So within 2 colors, or you can say with exactly 2 colors, we can color a non-trivial tree. So that's why the chromatic number of a tree is 2, and whenever the chromatic number of a tree is, or any graph is 2, then that graph is called 2 chromatic, or you can say bichromatic graph. So therefore the conclusion is that a tree with at least 2 vertices is definitely bichromatic. So overall what we have discussed in this session, again we have recalled the concept of n-chromatic graph. So what do you mean by n-chromatic graph? If the chromatic number of that graph is n, it is called n-chromatic graph. So what is bichromatic graph? If the chromatic number of that graph is 2, then it is bichromatic, or you can say 2 chromatic graph. Then we have considered one important result. If G is a non-trivial tree, then the chromatic number of that tree is 2. So it implies it is a bichromatic graph. So every non-trivial tree is bichromatic. So to clarify that concept, even we took one example on a tree. So how the coloring process is there. So if you start with any vertex and if you assign a color to a vertex V as red color, the vertices which are at even distance and odd distance, that is very important. So which are at even distance are colored with different color, which are at odd distance or sorry, which are at even distance and odd distance. So even distance means only 2, 4, 6 like that, which are at odd distance. Let me recall once again considering that example. Okay, so therefore here is an example. If you observe, we have started at this vertex, so which are at odd distance. So this is at odd distance, that's why color is different. 2, this is at odd distance, that's why 2. Which are at odd distance are colored with a different color, say 2. But which are at even distance, say this is at the even distance 2. So that's why the same color is used. So this vertex and this vertex, they are at even distance, 1, 2, 3, 4. The number of occurrences of edges are 4. So they are at even distance. So whenever the vertices are at even distance are colored with the same color, the vertices which are at the odd distance are colored with the color other than the previous color. So therefore overall conclusion is that a non-trivial tree is definitely bichromatic. Okay, so this is how we have discussed an important result on a tree. So these are the reference books already I have mentioned in the previous session also. So if you want, you can refer any of the books. With this we conclude the today's session. Okay, thank you.